Hi students, in this video we will be seeing about techniques for reducing ambiguity. Right, techniques for reducing ambiguity. There are some steps. The first step is if there is any epsilon production, you have to remove the epsilon production. Right, and next, if your start symbol is a nullable variable, you have to include at most one epsilon. You have to include at most one epsilon. And the third step is you have to remove recursive symmetric rules. Right, I tell once again, in reducing ambiguity, suppose if your grammar is ambiguous grammar and if you want to find the equivalent unambiguous grammar, there are three steps to be followed. The first step is you have to eliminate epsilon production. And while eliminating the epsilon production, if your start symbol is the nullable variable, you can include at most one epsilon. Right, that is your step 2. And the third step is you have to eliminate recursive symmetric rule. Right, so I'll tell all this what is recursive symmetric rule while doing the sum. So we'll go to our first sum. See, the question is find the equivalent unambiguous grammar. So it is understood this grammar is ambiguous grammar and I have to find the equivalent unambiguous grammar. Right? What is the first step? I have to eliminate epsilon production. Now look at the grammar. Is there any epsilon production? Yes. You know what is epsilon production? If the RHS has only epsilon, that production is epsilon production. So this grammar has epsilon production. So my first step is I have to eliminate this epsilon production. Right? Step 1. Step 1, I have to eliminate this epsilon production, eliminating epsilon production, and I have to make a tabular column. You know this tabular column has three columns: old variable, new variable, and the productions. Old variable, new variable, and the productions. So initially this old variable will be 5. Right? Initially this old variable will be 5. And I have only one epsilon production. I'll write this C tends to epsilon. No other production. So copy this variable to new variable. Right? And from new variable I am supposed to copy to old variable. Then from old variable to new variable. Right? And then I have to check if I substitute epsilon for C in the other productions, will I get only epsilon in RHS? Will I get only epsilon in RHS? Right? Right? So C tends to epsilon. Check the RHS for the variable C. Right? I have here T tends to A, B, C. So if I substitute null for C, what will I get? I get A, B. I am not getting only epsilon and RHS. Right? But here you check A tends to C, substitute, you will get epsilon. So you write this production A tends to C. Why I am writing? When I substitute epsilon for C, in RHS I am getting only epsilon. So you can write that production A tends to C. Similarly, I can write B tends to C. Right? Here again it is C tends to epsilon. I have already. And now I got two new variables. Include both A, B. Right? Now copy this new variable to old variable A, B and C. A, B and C. Right? Now use this production. Right? Substitute these production in the other productions and check whether you are getting only epsilon in RHS. Right? Only epsilon in RHS. So check for the variable A. Right? Yeah. Here I have T tends to A, B and C. Right? So for A I can substitute C. For B also I can substitute C. I have C. What about C? It is epsilon, epsilon, epsilon. It is nothing but epsilon. Right. So in RHS I am getting only epsilon. So I can write this projection. T tends to A, B, C. Right. Then I am checking for this A variable. Right. So A it is there. So A tends to A. So when I substitute, what is A? C. What about C? C is epsilon. So A into epsilon it is nothing but A. A into epsilon it is nothing but A. So I cannot write that production. I should get only epsilon and RHS. Right? Similarly, B also, I won't get only epsilon and RHS because I have a lowercase letter here, I won't get it. Right? So include this new variable T. Right? Next, what should I do? I have to write this new variable in old variable. A, B, C, T. Again here A, B, C, T. Right, A, B, C, T. Now check T I have here, right? T I have here. So S tends to A, T, A. So when I substitute, it is A, B, C, A. Right? So what I can substitute for A and B? It is C, 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 A. What about C? C it is epsilon. Right? What am I getting? I am getting A. I am not getting only epsilon and RHS. So I stop with this. Right? I stop with this. So step 1 is over. From this nullable variable, nullable variables are, what are the nullable variables? All the variables in my new variable. It is T, A, B and C. Right, next I have to do my step 2. Right, I rub this. I'll rub this and I'll do my step 2. Right, step 2, you know, given productions. Given productions. And resulting productions. Resulting productions. Right. So what are the given productions? S tends to, I have rubbed the question. Right. What are the productions? It is given in your question. All the productions you have to write. Right. So I will write all the productions. A, B and C. Next it is A tends to A, C, B tends to BB, C. Wait, I am writing my complete question. C tends to C. Right, C tends to C or epsilon. Since I am eliminating epsilon production, I won't write it. Right. Now in the step 1, I got T, A, B, C are nullable variable. So what is the meaning of this? For T, I can substitute null, epsilon. A, I can substitute epsilon. Similarly, for B and C, I can substitute epsilon. Right? So, given production, it is my complete question. Right? So, write the grammar as it is in resulting production. S tends to A, T, A. Then, say T is a nullable variable. So, I can substitute null for T. So, when I substitute null for T, what will I get? I will get only A. Right? Similarly, next production you write as it is first. A, B and C. First you write as it is. Right? Then you can see here all three variables A, B and C are nullable variable. So in that case you have to substitute one by one. Right. So first I substitute null for A. So when I substitute null for A, what will I get? I get B and C. If you want, I will do a show. So what is my prediction? T tends to A, B and C. Substitute null for A. So what you will get? You will get B, C. That's what I have done. Next, substitute null for B because all three variables are nullable variable. For A, B and C, I can substitute null. Right now. So next, substitute null for B. What you will get? You will get A and C. Next, substitute null for C. You will get A and B. Right there. You will get A and B. Right there. So what I told, one by one variable you have to substitute. Next, since all three variables are nullable variable, 2, 2 you have to substitute. First one by one, 2, 2. Suppose if there are four variables and all four variables are nullable variable, what you have to do? First one by one, then 2, 2, then 3, 3 and at last all four together. Right. So here one by one I have finished. Now I will substitute 2. Right. So take this prediction. A, B, C. Substitute null for first two variables. So what you will get? You will get C. Right. Next you substitute null for B and C. What you will get? A. Next you substitute null for first and last. What you will get? You will get B. Two variables I am substituting null. And then the third one, what I have to do, substitute null for all three together. Right. So when you substitute null for all three variables, right, what you will get? You will get only epsilon. But what am I doing in this step? I am eliminating epsilon production. So don't write that epsilon here. Right, you can stop with this. Right, you can stop with this. Next production, you write as it is. A tends to AA or C. Next, what I have to do? Write that. You know, A and C both are nullable variable. So in this prediction, what is that prediction? A tends to A. For this capital A, you substitute epsilon. So what you will get? You will get A. You write this. Right. Next, when you substitute epsilon for this C, what you will get? You will get epsilon. But what am I doing here? I am eliminating epsilon production, so don't do that. Don't write epsilon here. Right. Next, coming to the next one, write as it is. First, you have to write as it is. Right. You have to write as it is. B, B, C. Next, what I have to do? Check whether this B is a nullable variable. Yeah, B is a nullable variable. So you can substitute null. So when you substitute epsilon, what you will get? You will get B. Right? So when you substitute epsilon for this C, you will get epsilon. Only epsilon in RHS. But you should not do since we are eliminating epsilon production. Right? Next C tends to C. First I am writing as it is. And then I am checking whether the C variable is a nullable variable. It's a nullable variable. If I substitute epsilon for this C, in RHS I will get only epsilon. That becomes a epsilon production. But here what am I doing? I am eliminating epsilon production. So don't write epsilon production here. Right? So this is my resulting production. Now for the next step, you have to look at this resulting production. You have to look at this resulting production. As I said, in reducing ambiguity, that is to find the equivalent unambiguous grammar, first step is eliminating epsilon production and the second step is including at most one epsilon step. Right? So when I should include at most one epsilon, when the start symbol is a nullable variable, then only I can include at most one epsilon. Right, here the start symbol is yes. If you see the question, you can understand start symbol is yes. But here S is not a nullable variable. S is not a nullable variable, so no need to include at most one epsilon. I'll tell once again. If your start symbol is a nullable variable, you have to include at most one epsilon. Here my start symbol is not a nullable variable, so you won't get the next step. And step 3 is right, if there is any recursive symmetric rule, you have to eliminate such productions. Right, you have to eliminate such rules. So what do you mean by recursive symmetric rule? Right. So what do you mean by recursive symmetric rule? Suppose if you have some production like this, if you have any such production, that is left LHS, in RHS I should have this LHS 2 times. Right? So what is my LHS here? A. If I have capital A 2 times in RHS, that is a symmetric recursive rule. Right? We are learning context-free grammar, so always LHS will be a single non-terminal. Always my LHS will be a single non-terminal. I won't have something like this and all. Right? If I have any such rule, it is not a context-free grammar. So in a context-free grammar, always my LHS will be a single capital letter. It can be like this. So if this is your LHS, and in RHS, if you have this yes 2 times, then I can say this rule is the recursive rule. This rule is the recursive rule. Right? So if I have something like this now, this is not a symmetric recursive rule, because LHS is A and RHS I have 2 A's, but moreover I have a terminal. It is a combination of terminal and non-terminal, so it is not a recursive rule. This is a recursive rule, this is a recursive rule. Right, now check all the resulting productions whether you have any symmetric recursive rule. Right, so LHS is yes. If I have 2 times yes in RHS, I am having a symmetric recursive rule. Am I having? No. Take here T. Am I having any 2 T's in RHS? No. A. No. B. No. C. No. So no symmetric recursive rule also. Right. So this is your final answer. For this final answer, you can write the grammar G is equal to BTP. Yes. Thank you.